Good evening, students. Today we're going to discuss about that compiler design subject. It's related to that 21 CS 601. The subject code is compiler design subject code. And myself, Sharmila, assistant professor, Department of Computer Science in R.M.D.E. Engineering College. The objective, that is, we are going to discuss about how the compiler was built, what are the programming language used in that. If you are using high-level language, how that high-level language is converted into machine language. That is the point here. And how we going to use the compiler construction tools. What are the different construction tools available? How we going to generate scanners and parsers? How we going to parse each and every line inside your programming coding into a compiler? And how ritually it is happening, how the Java bytecode is converted. Then we're going to discuss about LLF1, that is left location passing, and LALR grammar. These are the different grammars we're going to discuss in the further coming videos. In the compiler, we're going to discuss about how to optimize the code, different techniques of that for optimization. And we're going to work on a large software project, how the optimized code works. These are the objective of the compiler design. First, we're going to discuss about what is compiler and what is interpreter. Here, the compilation is nothing but executing a program. After that, executing a source program, the compiler plays a role. How it plays a role is it converts each and every programming line into a tokens. Then the tokens is converted into a machine-independent language, and that is converted into a target program output, that is machine-understandable language. The source language into a semantically equivalent program written in a target language. That is a conversion of compilation. Here, the compiler and the interpreter. The interpretation is nothing but the performing the operation implied by the source program. That is, the source program, the input is given, when the program is executed line by line, then error is checked, then output is produced. That is called as interpretation. The analysis synthetic model of compilation is there are two parts of compilation. One is analysis, next one is synthesis. Analysis is nothing but the source program is converted into a particular intermediate language. That intermediate language is converted into a target program in the synthesis task. These are the two tasks available in the compilation. There are other different model, those are editors, pretty printer, static checker, interpreter, text formatter, silicon compiler, query interpreter. These are the different analysis synthetic model tools available. Here, what is the skeleton of this particular compilers, preprocessor, assembler, and linker we're going to discuss. The skeleton, that is a program. The source program is given to the preprocessor. The preprocessor converts that source program into a processed program. That source program is given to the compiler. The compiler will convert that source program into a target assembly language program. The assembler will convert assembly language into a relocatable object code. Then finally, the relocatable object code is converted into a linker. The linker convert relocatable object code into a mission, that is absolute mission code. That is a conversion of preprocessor, compiler, assembler, and linker. So in this video, what we have discussed is what is the main objective of this compiler design, and what are the different techniques we're going to learn, what are the different tools available, what is a compilation and what is interpretation, and two parts of compilation, one is analysis and then one is synthesis, and what are the different synthesis models available, like editor, that is syntax highlighting, and pretty printer, it is a doxgen, and static checker is a lint and splint, and interpreter, text formatter, silicon compiler, query interpreters, compilers, that is comes for database. These are different tools. And we discussed about what is preprocessor, what is compiler, what is assembler, what is linker, how is the conversion happening from the given source program into absolute machine code. So I hope you understand this basic concept of compilation and interpretation.